Hey guys, today we're going to tackle nth roots, and really the key to being good at nth roots is having a solid list of, all the perfect squares, perfect cubes, perfect fourth powers, perfect fifth powers in your head. If you feel good about, all these perfect squares, these perfect cubes, perfect fourths, perfect fifth powers, then you've really got a really, really solid foundation, and you're going to have a lot of success today. Now, perhaps maybe you're looking at this list and you're thinking, I have no idea why 2 to the 5th equals 32. Well, we're going to help you with that. So when we say 2 to the 5th, remember exponents represent repeated multiplication. We want to repeat multiplying 2 by itself 5 times. So it's going to be 2 times 2 times 2 times 2 times 2. And let's say those guys make 4. These 3 make 8, and 4 times 8 makes 32. That's one way you could think of it. And that's how we get 2 to the 5th equals 32. Well, today, nth root means we're going to flip the script a little bit. And we're going to say that the 5th root of 32 equals 2. And that's because 2 to the 5th equals 32. So that's what we're going to be getting into. So again, and right off the bat, we're saying, what are you going to see today? We're going to talk about how to do the 5th root of negative 32 and see why that's different than the 5th root of positive 32. We're going to talk about taking 64, raising it to the 1/3 power, or maybe takes 81 and raise it to the negative 3/4 power. So we're going to see a lot of fractional exponents, and those fractional exponents are going to get rewritten as, some type of root. So our definition of the nth root of a real number says, and we'll try to make some sense of this, the nth root of a is going to equal b, and that means that b raised to the n equals a. Okay, if n is the index and it's even, right? Even, emphasize that in our notebook. Then a is going to be, and the a is referring to this guy up here in this expression, is going to be non-negative, and b is also going to be non-negative. Okay, in other words, both a and b are going to be positive. However, if n is odd, right? Now all bets are off. A and b could both be positive or both be negative. Okay, I think I can guarantee that they're either both going to be positive or both going to be negative. I don't think you'll have a situation where A is positive and B is negative or vice versa. Okay, so let's try to make some sense out of that. So first of all, we're just going to warm up with completing the sentences, kind of like what we did up at the top of the last page. We'll say the cubed root or the 3rd root of 64 is equal to 4 because 4 to the 3rd equals 64. Or the square root of 81 is equal to 9 because why? Because 9 squared equals 81. Oh, my snowman got out of control there. Okay, the 4th root of 16 is equal to 2 because 2 to the 4th equals 16. And my experience is, students feel good about this. They're like, okay, I feel good about understanding why 2 to the 4th is equal to 16. And naturally, if you feel good about that, you're going to feel good about this in due time. Now, we're going to kind of go backwards a little bit. If I knew that negative 2 raised to the 3rd equals negative 8, I could say the cubed root of negative 8 equals negative 2. Again, that was 3 is an odd number, so we have an odd index, which means we can perform the cubed root of a negative 8. Now, if that was the square root of the negative 8 or the 4th root of negative 8, then we'd be crossing into the realm of imaginary numbers, but not if it's an odd root. If I said 3 to the 6th equals 729, I know that the 6th root of 729 is equal to 3. How about that? That's a big bear, huh? So anyway, what I'm thinking of, if I want to simplify the 5th root of negative 32, I'm really thinking, in my head, I'm thinking there's a number raised to the 5th power that's going to equal negative 32. So who is that number? Who would I raise to the 5th power to make negative 32? And the only possible answer is negative 2. Negative 2 to the 5th equals negative 32. So therefore, my final answer here is just negative 2. Okay, a couple of useful rules that come in handy. If you have the nth root of, this blue background isn't that great, is it? The nth root of a times b, you could kind of simplify that into the nth root of a times the nth root of b. Again, we're taking a bigger problem and we're breaking it into more manageable pieces. And I think with a lot of these problems, like if I can break them into more manageable pieces and kind of simplify the process, that's an advantage for us. Same thing here when you're dividing. If you have the nth root of the fraction a divided by b, just think of that as the nth root of a divided by the nth root of b. Two separate problems where you just divide their answers. Okay, we want to simplify the cubed root of 24. Now, if I was to make a list of perfect cubes on the side of my paper, one's a perfect cube, 8, 16, no, not 16, scratch that. 3 to the third is going to be 27, 4 to the third, 64, etc., etc., etc. Now, you'll notice 24 is not on that list, but 8 is on that list, and 24 is divisible by 8. So I'm going to rewrite this as the cubed root of 8 times 3. I'm going to use the rule we just saw above us and rewrite this as the cubed root of 8 times the cubed root of 3. And the cubed root of 8 makes 2. So I got 2 cubed root of 3 when I'm all done. All right. Now in this next one, I'm thinking fourth powers. So I'm going to make a little list on the side of my paper. 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, etc., etc., etc. Notice how fast they get really, really large. Really, really, really fast. Now, neither the 8 nor the 4 are on that list, but what if I multiplied them together, right? And I said the fourth root of 32. And now I said to myself, 32, again, is not on that list, but he is divisible by 16. So I could go the fourth root of 16 times 2, which is rewritten as the fourth root of 16 times the fourth root of 2, just making them more manageable. And the fourth root of 16 makes a cute little 2, and then you're just left with the fourth root of 2 right there. Boy, isn't this great stuff? This is good stuff. This is good, 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 good stuff. Again, I'm going to cheat off of that list we just had here, the perfect fourth root. So we're thinking 1, 16, 81, etc., etc. I'm going to rewrite this as the fourth root of my numerator divided by the fourth root of my denominator. And sweet Jesus, those are both perfect fourth powers. So this would be a 3, and this would be a 2, and we're all done. We're all done with that bear. All right. So the definition of a raised to a fraction, like 1 over n. So we could say, this is a lot of mumbo jumbo here, but it all makes sense when it's all said and done, I think. You've got the nth root of a, right? And that represents a real number where n is greater than or equal to 2. So your index always has to be at least 2, if not bigger, and it has to be an integer, okay? So n could be 3, 4, 5, 6, 7, but it can't be 2.5, it can't be 3.1, it can't be 4.75, right? It's got to be an integer, okay? And I think this is something we're pretty comfortable with already. A to the 1/nth is going to be the nth root of a. If you haven't seen that before, we're going to practice it. It's going to be okay. The denominator of the rational exponent, which is this part right here, becomes the radical's index, which is right there. So those numbers right here and here are going to match up, and that's all you got to look for. Then, of course, if that exponent's negative, we're just going to flip that expression to the denominator and then proceed as expected. Okay, so what I'm going to do here is I'm going to rewrite this as the square root of 64 raised to the first. Now, here's a situation where both if you have an index of 2, it could be invisible. And if you have an exponent of 1, it could be invisible. So like if I don't see a number right here, you always assume it's a 2. If you don't see a number right there, you're going to assume it's a 1. And once you simplify that, you get a nice, cool 8. All right, this is going to be the cubed root of 125 to the first. And the cubed root of 125 just makes 5. All right. Now, I'll tell you what, there's no parentheses around that negative 16, is there? So that negative's got to stay outside. And then we're going to do the fourth root of 16 to the first. And the fourth root of 16 makes 2. Carry the negative. Negative 2 is my answer. But in this next one, the negative is in the parentheses. So you would include the negative underneath your radical sign. And the cubed root of negative 27 is negative 3. Again, you may be wondering, how do you know that? How do I know that the cubed root of negative 27 is just a negative 3? Well, again, it's because negative 3 raised to the third makes negative 27. And understanding how those powers work is the key to understanding how the roots work. All right. Now, I want to say cubed root of 64, but I got to do a little more than that, right? I got to do 1 over the cubed root of 64 just because that exponent was negative. So we're going to end up with a 1/4 when we're all done. All right. One of my favorite movies of all time, Caddyshack. An oldie but a goodie, I tell you, oldie but a goodie. So he says, what if I got this expression a raised to a fraction? Instead of 1 over n, now it's m divided by n. Pretty much the same rules that you just saw in the previous example. All right. We're going to say the denominator of that rational exponent is equal to the index on that radical, right? And then watch this. The numerator is the exponent on the a once you're inside, okay? Now, where you put that m, you could put the m on the inside or on the outside of that radical. It technically doesn't matter. I prefer to put it on the outside here, right here, okay? And it's just a little, I always like to take the nth root first because that makes the number smaller before, and then once you raise that to the m power, it makes it bigger. So I like to make my numbers smaller before I make them bigger. If you do the opposite, and let's say you raise a to the m power first, now you're getting really, really big, and trying to take the nth root of those really big numbers can become a headache. All right. Let's see what this looks like. Oh, you're wondering, why is there a picture of Caddyshack? I almost skipped over this. I call this the Groundhog Rule, and that sounds really, really silly, and there's a good chance that that's going to make sense to nobody else but myself, but let me try to explain myself, and for some reason it makes sense in my mind, if nothing else. Just like this nice, cute little groundhog likes to kind of dig, burrow underground and pop up and smile at you there, this N is going to go underground, and he's going to pop up on the other side, and when he pops up, he's the index, okay? So it's the bottom half of that fraction is our so-called groundhog, and he's going to go underground and pop up on the other side as the index, okay? So let's put the Groundhog Rule into effect here. So we've got this 3 is the groundhog. He's going to go underground, pop up on the other side, and we got the cubed root of 27. I like to put parentheses and square it. So the cubed root of 27 makes 3, and 3 squared makes 9. Piece of cake. Okay, who's your groundhog? 2's the groundhog. He's going to go underground. He's going to pop up. We've got the square root of 9, and that 2 is optional. I usually wouldn't write that. Square root of 9 makes 3. 3 to the third makes 27. Piece of cake. All right. I am going to put everything under 1 because of the negative exponent. And the 4 is the groundhog, right? So we're going to do 4th root of 81 raised to the third. Now, what is the 4th root of 81? Well, that just makes 3. And 3 to the third is going to make a 27. So 1/27th is our final answer there. I'll tell you what, this is a real doozy. If you feel good about that problem, if you feel good about how you're going to handle your negative exponent, how you're going to handle that fractional exponent, you are in good shape. There's really nothing that I can throw at you that you can't handle. So that does it for tonight. So keep practicing. The more we practice, the better we're going to get. I guarantee it.